Okay, ladies and gentlemen, good morning to you guys. I hope you're well. Let's take a look at where we're at. October 4th. Remember, your lectures are recorded. They are online in Canvas under lectures, right? I want to share with you guys a little something today. I want to get started on something that's kind of important. I mean, it's all important. You might say, really? We have something known as chain rule, ladies and gentlemen. Okay, just kind of get started on some chain rule here for you guys. And I'll put that link here. And, you know, chain rule is something where if I said to you, let me go back here now. Of course, you do have the videos too. You guys are aware of that, right? Anybody watch and look at the videos by any chance? Yep. Good. You find it helpful? Good. That's the whole idea. So let's continue. And chain rule for derivatives. Now, I want you guys to note the setting, why we have chain rule. Remember, you're really trying to determine a derivative, and we started to see how we can apply that derivative. We just started to see how to apply it, right? So we're still working on, in some ways, a little bit of how to apply it and then a lot of the mechanics behind it. So, I mean, you can't apply it if you can't do the mechanics. You guys know what I'm saying? So, I mean, so there's mechanics behind this. So, all right, we want to determine a derivative. That's a first derivative. And, you know, what if you had functions that look like this, right? You said they gave me maybe 3x minus 2 in parentheses, and they raise that to the 10th power. And they want you to find a derivative, okay? And let's do this a little bit more clear. And you might say, are you serious, Mr. Judge? Would you do this to us? And I'd say, yeah, that's in your future. You go, but you want me to use FOIL to the 10th power? And I'll say, actually, no. There's another way to approach it. What if you had a function that looked like this? Sine of not x, but x what? Squared. You can't actually differentiate this function, ladies and gentlemen, with the tools you guys already have. Okay, what if they give you a function, the square root of maybe 5x plus 4? Another function, I don't know, maybe tangent of 3x now, okay? So what we want to learn how to do is how to differentiate all of these functions. And how you do that is to use what's known as what? Yeah, we must use chain rule. Okay? It's kind of a major topic. It's based on learning how to do a derivative, but it's really based on, in case you guys didn't know, you say, in my mind, I have it organized. Chain rule is when you take derivatives of composition of functions. Okay, so if you guys remember, what are composition? It's really based on composition of function. So, you guys remember this thing called fog? Do you remember fog? What's fog? That's f of what? G of x. F of what? G of x. So I want you guys to know this here. This is a big deal. You see this inside portion here? I call this here the inside function. Okay? There's like a function inside another what? Function. This is the inside function. So that G is inside of what? F. Okay? So the inside function is G. All right. Now, here's the deal, right? So let's see what else we can do here, right? So very often we let y be f of g of x. You have an inside function. So y then becomes this f of g of x. Now, what I want to find is the derivative of y. And so I'm going to write it down this way. Let me do it this way. I'll change colors on you guys. You don't have to. But I'm going to say y is f of g of what? X. So that y prime, ladies and gentlemen, is going to be, I'm going to prove this to you guys, f of g of x times g prime of x, where, again, g is the what? It's the inside function. Okay, now this over here is the same g, but you're getting the derivative. That's actually chain rule, ladies and gentlemen, believe it or not. And there's kind of a proof for it, so you guys know. Okay, the proof is kind of, if I said to you guys, dy dx, this is what we mean by y prime, okay? And there is another definition that's equivalent to, right? This is my difference quotient. This is that slope, change in y, change in x. And you're going to say that derivative here, the change in x goes to 0. That's really the the definition of derivative as well. So you guys know. And then what you can do is you can focus on this portion here. I know the proof doesn't seem to, the proof is interesting. I'm going to put dy here. I'm going to write this as a fraction. This is dx. So what I'm going to put now here, this will be du. Delta u. So notice this. If this was algebra, right? I mean, don't do this, but don't cancel. But I want you guys to see what I just did here. What I did is I put the du's, the delta u's, the change in y. Remember, change in y, change of x, these deltas, that's the slope of the secant line. So the proof of chain rule really becomes this. It's a limit as the delta x goes to 0, delta y, delta u, u, times delta u, delta x. You're going to use what rule again? The product rule. Take the limit, delta x goes to 0, delta y, delta u, times the limit, delta x goes to 0, delta u, delta x, because the limit of a product is product of limits. So all along, my dy dx is really what you see here all along. And so what we do here is we say to you that this portion here in orange, this portion here in green, that is equal to dy du times du dx. And that is really our introduction to chain what? Chain rule. Okay, where this orange portion here is dy du, and then this green portion is du dx. Chain rule. And that's actually going to be the same thing. We're going to see this here, okay? Because what that means is this portion is u. That's your u. And we're going to have to identify, go about how to find the inside function. It's simple, but it does take some work. It's not as intuitive, but for some people it's intuitive. For me, I had to do my homework a few times on this topic, right? So, like for example, 3x minus 2 to the 10th power, right? Okay? This is really a composition of functions here. So I'm going to get, I could use either version here because I'm giving you guys a couple of versions of it. Maybe the best is to start with this version here, right? And what I tell students with this version is, if you're going to use that version, you want to identify the inside function. What's the inside function? Okay, so in composition of functions, you guys remember compositions, how that worked? Right? F of g of x. So go back and think of this here, right? F of g of x. The real picture of this is like g. And you're going to drop what in that thing? Right? You're going to drop what? right? You drop your function in g. You guys remember that? So you have what's called an inside function. It's a domain there, right? So in this example, right, or in my format, g is always the inside function. So when you see the function now, y is 3x minus 2 to the 10th power, what's the story here? What function is inside? Really simple. What's inside the parentheses? Yeah, you see this linear equation? It's kind of simple. This is your u. That's the inside function. All right, you guys okay with that? What's in that parentheses is what's in is the inside function. That's your g. So, okay. You said, well, how do I use this? Well, here's how the book will want you to start, right? The book will say, let u be what? 3x minus 2. That's what the book says. What does y become then? Then that means your y will be what? See this? What is y now? It's u to the what? 10th power. You guys okay with that? Okay. Okay, so I have to show you guys this notation. All right, so what does this chain rule say I do? Okay, I'm going to show you guys how it's all connected. What does that chain rule say I need to do? Do you guys see it? What do I need? I need this orange part. What's the orange part? Okay, y prime, which is dy dx. I want to write that down. I want to keep track of that. dy dx. What is, I need dy with respect to u. So here's y and here's u. What's that derivative? Can you guys tell me here? In orange, they want this derivative. What's that? 10u to the what? 9th power. You guys see, this is the first part in chain rule. Okay, that's your first part. It's going to take some practice. It took me practice as a student. Now, what's the green portion? I need du what? With respect to x. So what is that going to be? Well, you got to go back where? Up here. Okay, this is my u with respect to what? X. So I'm going to write it down this way here. Okay. What is du dx? You guys know? Well, I differentiate with respect to x my u, which is 3x minus what? 2. What does that give you? Is that 3? Okay. So, ladies and gentlemen, that portion is what? 3. Okay, you guys see what I just did? So, you know, we're going to have to identify the inside function and call it u. We're going to start by doing this in a couple of steps. And then after our instincts become really good with this, I can show you kind of how you can really step back and look at it. But let's write this down. What they're saying now is this. Go back. dy dx is 10u to the 9th times what? Times 3. Orange, what's this? Green. What is u, ladies and gentlemen? What was the inside function in this question? Is it 3x minus 2? So, ladies and gentlemen, go back and replace your u with what it is. U was what? 3x minus 2. So, by chain rule, ladies and gentlemen, dy dx becomes 10 3x minus 2 to the 9th times 3. So, this still If you said I like the colors, this is still in orange, and then this is going to be what? Green. But you guys know what you can do? You guys can multiply, right? Make sure you do that. What's 3 times 10? 30. 3x minus 2 to the what? 9th power. There it is, ladies and gentlemen. That's your derivative by what? Chain rule. So, you know, I like to, in a calculus class, get started on those kind of things because it may take some time for you to what? To do this process. It may take some time. I know when I was a student, it took some time for me. I remember I used to sit with my book open. I did all the homework questions, and I didn't feel like I had enough practice. And then you know what I did? See, back then, we didn't have the internet. Then I went to the library and another calculus book, and I got those questions, and I tried to do those derivatives too. So I do like $2, $3. Because I was one of those kids. I had to practice. Now I could do it in my sleep. I could look at him and tell you what it is. Because of what? Practice. If you do it the night before, is that going to be helpful? No, it just doesn't work that way. That's why I want to get started when? Now. Give you a good, yeah, exactly. Give you a weekend to, you know, Mr. Judge, is my weekend going to be chain rule? Well, hopefully. Because it might take some time for it to sink in. And that's normal. That's not abnormal. Don't think there's something wrong because it took you time. You know. Let's try another. You want to see y is sine x squared? You go, how do you do y is sine x squared? I'm going to do the exact same procedure, okay? Y equals sine x squared. I can do that in my sleep. Again, what is the inside function here, you think? The x squared, what's between your parentheses? Call that what? Call that u, ladies and gentlemen. Okay. So, you know, I write it down, right? Say u is what? X squared. That's what you just did. You're labeling the inside function u, and it's equal to x squared. Now, what does that mean? That means since u is x squared, doesn't that mean y is sine of what? U? All right. So far, so good? Okay. Now, write this down. Write this formula down. dy dx becomes dy du times my du what? Dx. Okay, so this is going to be 2 derivatives now for the price of 1. I got to get the dy du, and then I got to get the what? Du dx. So, okay, you might say, where is my y with respect to u? It's right here. You guys okay with that? Where is the x with respect to u? It's not u. It's u versus x. It's in green right there. So I just want to color coordinate this because I want you guys to see that. All right. You guys okay with that? Pretty simple. Is that true? Okay. Let's focus. dy du. That's right here. What's that derivative? Can you tell me what the derivative of sine is? Yes. So dy du is going to be what? This is cosine u. You're looking at this, y versus u. So you know the derivative of sine is what? Cosine. There you go. You're almost there. You're halfway there. You need what? Du dx. So you might say, what is du with respect to x? Use your operator notation. Do you guys know what this is? What is this? That's 2x. So, ladies and gentlemen, this is known as the chain, by the way. In chain rule, this is called the chain. So your chain is that 2x multiple. You're almost done. Look at that. What do you guys think you have to do now? You're almost there. The very last step is you got to go back and remember, what was u? X squared. So you go back and you say, okay, dy dx here is cosine of x squared times 2x. What do you do with that multiple? Dy dx, and you're looking back at the book, you know what they want to do? Since the order in which you multiply doesn't matter, they're going to actually switch that order on you, where this is that orange portion, which is going to be here, and then this is the green portion, which is here. Now, it doesn't matter. The first one would be fine if you left it that way. But you might get confused and go, Mr. Judge, how come they have the 2x first and the cosine x squared second? I'll say, well, the order in which you multiply doesn't matter, so you can do that. But by tradition, we like to have those linear terms in front of our cosines and sines and tangents, in front of our trig functions. And that's it. It doesn't matter, but, you know, I mean, when I used to look at, you know, when you're looking back at the book and you see the answer, don't you want to see exactly what you got? You guys know what I mean? I was like, oh, my God, how come I got cosine x squared times 2x? And it's always 2x times cosine x squared. Well, they just switched the order. So I want you guys to know that it's not that big of a deal, but there it is. What do you guys think? Now that you've seen your second problem, does that look scary? No. Let's look at this one here. Let's look at what? Oh, the square root of 5x plus 4? Oh, my God. Okay, we're going to have to differentiate this now. Now you might say, Mr. Judge, I don't see a parentheses. And I'll say, okay, can I write this 5x plus 4 to the 1/2 power? Because that's what that is. Do you guys see a parentheses now? What's your inside function? What's in between the parentheses? Is that right? You guys okay with this? So this is what? That's your u. So you're going to write down, what does u equal? And what is y going to be? U to the 1/2. All right, you guys see that there? And then write down your chain rule, which will be dy dx. That's actually what they're looking for, is dy du times du what? Dx. So in orange, I have this. In green, where's my orange? Right here. Where's the green? Over here. So I'm going to get out some more space for you guys. Chain rule. All right, so take a close look at all of this here. Okay, you guys ready for this here? You guys ready? What do you have to do first? You need what? dy du. So you're looking at this portion here. Here's y versus u. So what do you guys think? What is dy du going to be? Did you memorize that one? 1/2 square root of u. Is that right? Do you guys remember I said that one shows up a lot? That's one you do want to memorize. So you say, is that going to be 1 over 2 square root of u? Absolutely. Okay? And then, what do you do next? We need to find du dx. How do we get du dx, ladies and gentlemen? Go up here, okay? It's right here. This is what your u with respect to x. So, du dx will be d dx. What is that u? 5x plus 4. What's that derivative? Is that 5? Okay. What do you guys think you just found? In green. This is the chain portion, okay? This is going to be what? 5. This is your chain. This is what we call the chain. But you're not done. What's the very last thing you got to go back and do? You guys remember? You got to tell me what u was. 5x plus 4. But don't forget, simplify. You might say, what do you mean? Multiply what? 5 over what? 2. Square root what? 5x plus 4. There it is. Okay, you're multiplying that fraction here. What do you guys think? Is that one okay? Easy peasy lemon squeezy? I bet you didn't realize you could differentiate these this morning. You can. And you could do it. If I could do it, you guys can do it. Tangent 3x. This is probably a day you don't want to miss. Is that right? Huh? Well, because I know I was a student before. I remember, like, oh my God. And I remember, I mean, if you're kind of the student there's kind of a, what is it called? You're intermittent. You guys know what I mean? It's like if you were to watch a movie, you sat down to watch a movie, and you only, every 5 minutes, you got up to use the restroom, or you got up to go do something. Okay, every 10 minutes, right? Are you going to know what's going on in the movie? You see what I mean? That's kind of how it is. I think it's just like, wow. I mean, and then math is, and that's kind of the problem in some ways, because math builds on the information you already knew. So, like even this derivative, I can say, you say, okay, what did I learn today? I learned that these functions are really compositions where you have an inside function. And the inside function is what? You know. And composition you did in like pre-calculus and intermediate algebra kind of thing. So, you know, if you did Fogg and Goff, you guys remember? You even see it. Yeah, Fogg and Goff. Huh? No, Fogg and Goff is what they call composition of functions, f of g. And then g is g of f. And then you can show the inverse functions. There's Fogg equals Goff, and it equals x. It's really what they mean by an inverse function. So, you know, those are the things. What you're looking at is really Fogg. The inside function is g, or we're calling it u now. Because you can kind of get really heavy with notation. Okay. So write it down. What was u then? 3x? So if u is now 3x, what does it mean y then is? Y is tangent of what? u. Okay? And then write down chain rule. You say, if I have to find dy dx, I do. That's dy d what? U times your du what? Dx. All right, you guys okay with that one? So let me give it the colors. We need dy du first, and then we need du what? Dx second. So let's get those things, okay? So here is what we need. So we're going to say, okay, what's dy du? Do you guys know? I mean, maybe you said, I want to see your operator notation. Okay, maybe that's helpful. What's the derivative of tangent? Isn't that secant squared? Is that true? Okay. What's du dx then? What's that going to be? That's what? 3. All right, so what do you guys write down here? No, what happened? Dy dx. What do you guys get here? What's dy du? That's secant squared u. And then what's du dx? That's the chain. That's just the number 3. So let's get out our colors so you can see it. The last one we want to put back is what our u is. What is u? The inside function is what? It's 3x. Is that right? Okay, final answer. You said, Mr. Judge, I looked in back of the book and I seen 3 times that secant squared of what? 3x. Yeah, because they like putting the constant in front of your function. And there it is, ladies and gentlemen. Easy peasy what? Lemon squeezy. Okay, so we have you guys try some. What do you guys think? It's always good to get you guys on this, right? You're going to have to determine, you know, they'll say determine y prime or find y prime. Determine. Y, yes. Yeah.
Right there where it says 3 secant 3 times secant squared 3x.
Mm-hmm. Yeah. They switch the order.
Oh, okay.
Yeah, because they like putting the constants in front of the functions. And be careful. Don't multiply 3 with 3x and get 9x. Because that's function notation, the parentheses. Right? That's not product. So, yeah, very often you'll see, hey, they put 3. They just switched the order. Remember, multiplication is commutative. What does it mean? The order in which you multiply doesn't matter. That's what it means. So I'm going to say try number 1. Y is x plus 7 to the 5th power. Try number 2. Y is the cube root of 2x plus 1. Number 3, y is cosine of 2x. Number 4. Y is a square root of 1 plus x squared. Okay, we're going to try some of these out. I'll give you guys some time here. Where's our clock? Let's try these out. Okay, at least get a few of them under our belt, right? So let's try this, okay? So ladies and gentlemen, what's the inside function for the first one? There it is, x plus 7. You guys okay with that? So far, so good? U is x plus 7. What does that mean y will be then? Isn't y u to the 5th power? Okay. What's chain rule? dy dx is dy du, right, times du dx. Okay. So here's my orange. This is what I do first. Here's green. This is the chain. Okay. All right. So dy du becomes d du of what? U to the 5th power. What is this going to give you? What do you guys get here? Isn't this going to be what? 5u to the 4th? Okay, so this portion is 5u to the 4th. Is that true? Now I need the chain. You say, what's the chain? The chain is du, derivative of u with respect to x. And if you want to see the operator notation, what's the derivative of x plus 7? Isn't that 1? Say, Mr. Judge, can the chain be 1? Yes. So dy dx is 5u to the 4th. Okay, but what was u to begin with? It's right here, isn't it? Isn't it x plus 7? So, final answer. Five x plus 7 to the what? 4th. There you go, ladies and gentlemen. What do you guys think? Easy peasy lemon what? Easy peasy lemon squeezy? What do you guys think? Is that good? All right. Y is what? 2x plus 1. What's your power now? Isn't that 1/3? Right? That's the cube root. That's a cube root, ladies and gentlemen. So that's 1/3. What will be the inside function now? What's inside your parentheses? Isn't that 2x plus 1 inside the parentheses? Okay, so here u will be what? 2x plus 1. Y then will be u to the 1/3. Okay, you guys see that there? Need some space. Okay, so we know dy dx. What's chain rule? Is dy du times du dx. Here, where else? Here. What's dy du? What is that? Isn't that what? 1/3 u to the 1/3 minus 1. Is that true? And so we're going to have to subtract there. So this becomes 1/3 u to the minus what? 2/3. 1/3 times 1 over u to the positive 2/3, which will be 1 over 3 cube root of what? U squared. Okay, you guys okay with that one? That look fine? I believe so. You say why? Because remember, if you go back to, I don't know, even intermediate algebra, u to the n over m is the mth root of what? U to the n. Okay, now what else do we need? We need what? Du dx. What's that going to be? Aren't we differentiating 2x plus 1, which equals? Isn't that 2? Okay, you guys see that there? So let's write this down. This will be 1 over 3 cube root of u squared times, oh, it looks like it's just times 2. The chain is just a 2. Okay. And of course, that's multiplying a fraction with a whole number, which means I just multiply the numerator by 2. So you get 2, 3, cube root of what now? U squared. But what is u? Isn't u 2x plus 1? Okay, so you're going to have to put in a 2x plus 1 for u. Let's see what that is. 2x plus 1. Because this is where the u is. Kind of weird. Doesn't let me. What? I don't know what that is. Doesn't let me draw a rectangle. Anyway, there you go, ladies and gentlemen. Pretty good. Was number 3 easy? Well, let's see. What is u? What's the inside function? Right? U is going to be what? That 2x. So we say, okay, u is 2x. That means y will be cosine not of 2x, cosine u. Chain rule, dy dx will be dy du times du dx. So we're going to now say, okay, dy du. What's the derivative of cosine? Is that negative sign? What's the derivative of u with respect to x? Isn't that 2? Have you done enough derivatives in your life where you can actually start to write it down this way? You guys know what I'm saying? Hopefully you started your homework on derivatives. Okay, so you're going to get what? dy dx. What's dy du? Minus what? Sine u. What's du dx? Times 2. Negative 2 sine of u. What was u to begin with? It's right here. It's what? 2x. Plug in that 2x there. And you are what? Done. All right, let's try to get this one in here. Was this one fun? Is that one to the 1/2, ladies and gentlemen? This one, you guys okay with this one? What's the inside function? Yeah, isn't the inside function between your parentheses? So u will be whatever is between those parentheses. And now that means y becomes u to the what? 1/2. Okay? dy dx is dy du times du dx. All right, you guys okay with that? So what is dy du? Isn't that 1/2 square root of u? Didn't you memorize that one? And what about this one? This one's hard, is that right? Maybe I need my operator notation for this one. I'm going to have to maybe move everything down here. You say, what is your point here, right? So if you really have to go into your operator notation to find du dx, I think this is a really phenomenal what? Notation. So hopefully you guys have already done enough of the homework where you already know what these kind of derivatives are, because like I said, your main challenge now is not doing this necessarily, right? Your main challenge now is to put it all together. So, okay, so this is what du dx is, right? So you say, is du dx 1 plus 2x? And the answer is what? Yes, because after a while, you could just look at this and you could just say 1 plus 2x. Do you guys know what I'm saying? If you do enough practice, you get there 1 plus 2x. It only comes with practice. So I actually used to sit at home watching baseball games and work on calculus. I remember, I can even tell you how old I was. I was working on chain roll as the Dodgers were beating the Oakland A's in the '88 World Series. Should have been an omen. I remember sitting there at home, paying attention to the game and working on chain roll. So, yeah. Absolutely. So whatever you guys are, you know, I don't know, you guys are different. Maybe you're on Netflix. Next time you're on Netflix, get out your what? Your chain rule. Don't forget, this is 1 plus 2x, right? And what was u? U was what? 1 plus x squared. That was our u, 1 plus x squared. So I'm going to plug in here for that u, 1 plus x squared, okay? So let's put it all together. If you look in back of the book, you're going to see 1 plus 2x over 2 times the square root of 1 plus x squared. And yes, this is our introduction to what? Chain what? Rule. They should call it pain rule. I don't know. You say, Mr. Judge, is this pain rule? No, it's chain rule. Because what is always known as the chain? You guys know this is This is referred to as the chain. The DUDX is a chain. So try some of these out, ladies and gentlemen. I have it on my website. Okay, this is chain rule, and then you got the video on chain rule as I went through those chain rule questions. And I put that even in Canvas. In the assignment portion to start giving you guys the odd numbered questions. Chain rule, odds. There you go. Take care. We're going to work on more chain rule tomorrow, but don't wait till tomorrow. I'll see you guys later. Have a great day. Ladies and gentlemen, let's see here. Let's see this video. Sorry for the late start, but let's see what I can do here. What am I doing? There you go. You got your what? You got your video there, okay? And what we were working on yesterday. Do you guys remember? Chain rule. Now I'm gonna do something here. I'm gonna try to get my website. All right, and let's go to 261 worksheets and videos, chain rule again. Okay, so I'm going to place this here online for you guys. All right. Okay, now, so we're going to get to do some chain rule again. And what I'll do here is give you kind of like an example here. Okay, maybe we'll start to do this number 1, where you have a function, and now I could use y, but we can use f of x, okay? We can interchange our notation. So you have x minus 5 cubed, x plus 3 squared. Okay? And I'm going to do it a little bit differently. Okay? I'm going to do this a little differently for you guys here. Okay? I want you guys to note something here. I can give you a visualization of what you're seeing here. Okay? So if your function, I'm going to put a triangle to the nth power, where obviously this is the base. Is that true? So let me draw a picture of here's your function, here's your derivative. And triangle to the nth power minus 1 times the derivative of the triangle here. Okay, so this is thought of as power rule. Okay, but it's chain rule and power rule. So let's write it down, power rule with what? With chain rule. Because this portion is your chain, and I think this would be good, right? This is the what? Chain. All right, you guys see this picture? The power rule is on the left and the chain is on the what? Right, okay? Now, you might say, why is that beneficial for us? Because if I'm going to try to find the derivative of the function, let's do operator notation, okay? Meaning you have what? X minus 5 cubed over x plus 3 squared. Okay? So you guys see that here? Okay, this is operator what? Notation. And yes, that is the same as what? Y prime, because y equals f of x. Okay, so that's the same. All right. Okay, here we go, ladies and gentlemen. So what are you guys looking at now? Because this is the second installment of chain rule. This is going to be the product what? Rule, right? So there's a product there, okay? So remember how we do this. Don't we pull out the first function, right? And then we differentiate the what? Second function. So y prime will be x minus 5 cubed d dx of x plus 3 squared plus the x plus 3 squared d dx of what? X minus 5 cubed. Okay, is this product rule? Do you guys remember? Do you guys see my point? Okay, so when I say to you guys, you got to take this derivative here and this derivative here. Okay? What are those derivatives? This is where this idea of what? Power rule with that chain rule comes in. This is where you guys want to really get used to this. And in fact, this is a picture Mr. Escalante used to draw for us. He used to use the triangles, you know. That was the notation he brought to the table. And that is actually chain rule, by the way. It's a picture of chain rule if you could draw one. Now you might say, how is that a picture? Well, let's take a look at the detail, right? So I'm going to put this as a note for you guys so it's very clear. If you differentiate by chain rule, x plus 3 to the second power, right? You're going to use the power rule portion here. You see that? Oops. This is the base, right? So this is going to be, ladies and gentlemen, 2 times what? X plus 3, 2 minus 1. Is that power rule, ladies and gentlemen? But do not forget what? This is going to be, I'm going to have to move that because I don't want it to even be where? On the side. This is the chain portion. Okay? Chain portion. You now have to differentiate with respect to x, the base of x plus 3. So there it is. This is the picture that I'm drawing here for you guys, okay? There that is. And then that's going to be 2 times x plus 3. 2 minus 1 is 1. Is that true? And what's the derivative of x plus 3? You say, I know, that's 1. So the chain portion is just times 1. So you end up with 2 times what? X plus 3. And there it is, ladies and gentlemen. That's the first part. So if you guys see this, this is kind of a, you know, trying to say, hey, let's revisit what? Let's revisit some of these derivatives here, just to give you guys an example. Now, that's the first one. What's the second one we got to do? It's right in here. Derivative with respect to x, x minus 5 cubed. So, here we go. Three, x minus 5, 3 minus 1, times the derivative of what? X minus 5. 3, x minus 5 squared. Do you guys know what is this derivative? 1. So this is the chain portion. I'll put the chain portion in red. So what do you guys end up getting now? This will be 3 times what? X minus 5 squared. So, ladies and gentlemen, what is that? 3 times x minus 5 squared. Okay, so I'm going to write this down. And then we got to put this all together. So we're looking at chain rule again, but we're looking at it in a context of product rule, just so you guys see what's coming type of thing. Okay, just so you guys see what's coming. But we'll do some work on that. Okay, so let's do this here. All right, you guys ready? Let's write this all down. So this will be y equals 1, the x minus 5 cubed times 2 times x plus 3. Was that cube? Yes. And this will be times 2 times x plus what? 3. Plus x plus 3 squared times 3 times x minus 5 squared. So 2, 3. That'll be 2. And then I'm gonna say something to you guys here, okay? You're gonna have to write. You're gonna have to write this. Try to be consistent. Put your constants in front, and then you have the product of terms here, okay? Now I'm gonna put the x plus 3 squared. Oh, don't forget that 3. Times x minus 5 squared. Okay, you guys good with this? Now, I'm going to do something here that's coming up for us. Just so you guys know, can we simplify? And the answer is yes. And we're going to start to work with this in some detail. Okay? Now, you might say, how do we simplify? Well, they don't want you to multiply. They don't want you to use FOIL. They don't want you to do that kind of stuff. Okay, when they say simplify, we're going to learn, ladies and gentlemen, this is what's coming on in our future. How to what? Factor. And you might say, how to factor? Factor what? We're going to factor out the greatest common factor. And I think I made a mistake. Who did I make a mistake? I didn't make a mistake. I made the order. So I want you guys to put the order this way. X minus 5 squared. Okay, there's going to be a reason. And then the x plus 3 squared. So I apologize, but let me get some colors out so you guys can see my point. I don't know which ones to use, but okay, we'll try pink. Well, we can kind of use the same colors we had up here. What do we have? Orange for x minus 5. I'm going to do that. Here, orange. And then what? Green. Now, I want you guys to know, yes, we're going to work on that. I even think I did a video of some algebra because this is something that students have to learn. I had to learn this as a calculus student. I didn't realize you can do this. Here's what I mean by that. We're going to factor out x minus 5 squared and x plus 3 to the first power. Okay? Now, this is known as the greatest common what? Factor. This is actually from beginning algebra. And if you guys remember from beginning algebra, that's going to be times a quotient. And you might say, how do I get that quotient, right? I could kind of look at it, and I could say, the quotient is 2 times x minus 5 and plus 3 times x plus 3 here. So in purple, this is our what? Our quotient. And so now, ladies and gentlemen, you say y prime will be x minus 5 squared, x plus 3, and you could now do your simplification here. And that's what's coming in our future here, to let you guys know. You're going to now end up with here, 2x minus 10 plus 3x plus our 9. So your derivative now will be x minus 5 squared, x plus 3, 5x minus 1. All right, you guys okay with that? So you say, Mr. Judge, is that what they expect me to do? Yes, in our future, absolutely.
Do we have to do it now?
In theory, yes. But I think from my experience teaching calculus, let's go back, okay? From my experience, if I go back over here, I have something called, where was it? Okay, because we're going to use this stuff. I did this chain rule again, but I haven't done all the details with that. But I do have, where is the algebra, just so you guys can see. I seen it the other day. Go algebra for what? Calculus students. So I'm going to click on that. I actually already sent that to you guys, okay? And let's go over here. And what I have here is a video, because what you're starting to see, remember I said to you, you guys can factor out the greatest common factor in this problem? Here's some examples of factoring out the greatest common factor. Maybe I got to do another one. I don't know, but that video is here for you guys, okay? So this is where we're headed, is what I'm saying. There it is right here. What is that? Writing? Oh. Anyway. Thanks, Chief. You're welcome. Chief. Anyway. How many likes? 13 likes. Oh, wait a minute. That's not the algebra. Where's the algebra? Did I click on the wrong one? Sometimes, let me be careful. Sometimes I have to click. Yeah, let's see what happens. There should be an algebra there. There we go. I got to click on the middle of it. How many? Only 7 likes. Oh, I guess number 15 was wrong. 202. Is that good? I don't know. But ladies and gentlemen, here's, like I said, this is the idea between, this is where we're headed with that factoring out the greatest common factor. Okay, you guys just seen an example where you said, hey, do they expect me to do this? Yes, they expect you to. This is why you guys want to know how to what? Differentiate. This is why you don't wait the night before to learn how to take a derivative, because now you got chain rule and now you got some algebra simplification too. Because they can ask you, hey, you see this nice function? Yes. Where does it have horizontal tangents? So if you just stop right here with your derivatives, there is no way you're going to find horizontal tangents. So why we do this, just to give you guys a whole heads up, is because with some of the applications, like finding what? Horizontal tangents, you got to do the algebra. And x minus 5, how do you find horizontal tangents again? Do you guys remember? You set your first derivative equal to 0, and then you what? Solve for x. So you get this here. Okay, you guys see my point? This is why you want to do the algebra, because eventually you're going to have to say, oh, that means x minus 5 is 0. You're using the zero product rule, and x equals 5. Then this is one location. Okay? And then you're going to do what? Subtract 3 from both sides, and you're going to get what? X is negative 3. And then here, you're going to get 5x is 1. Adding 1 and divide both sides by 5. So, ladies and gentlemen, there's 3 locations here. Yes, you could get the point, get the y coordinates. But there's 3 locations where you have horizontal tangents. So, where you're headed, ladies and gentlemen, yes, requires you to do what? The algebra. And to know chain rule. So if I went to Desmos, you go, what are you talking about in Desmos? We can actually see that whole thing. Okay? If I even punch this function in, x minus 5 cubed, x plus 3 squared in Desmos. What was that? X plus what? Is it x plus 3, I think? It's x plus 3 squared, right? Yeah. Okay. So, let's double check. Horizontal tangents. This is, the aspect ratio to this is not really very good, and we can adjust it, but whatever. You know, that's not a horizontal tangent. Where do they have horizontal tangents?
At 5, -3.
At 5? Do we have a horizontal tangent at 5? No, there's no. Yeah, that's not a. Did we make a mistake? Do we have at 5? Oh, that's weird. I don't know. Maybe we made a mistake in the algebra, or maybe I put that wrong function in. X minus 5 cubed, x plus 3 squared. That's weird. We're going to have to take a look at it. Okay, so I apologize to you guys. But yeah, that's where we're headed. So I would say to you guys, we really want to work on what? Chain rule and power rule. All right, you guys okay with that? So let's work on this here. Let me share with you guys this. 3x minus maybe 1 to the 4th power. Could you guys find that derivative, right? Let's look at this in terms of our operator notation, because this is where we're headed, right? So we're going to have this chain rule again, But now let's consider this as operator notation. Now you might say, what do I mean by that? You see your function looks like this. Is that right? What's the base? Isn't this your base? And then what do you guys have? Your power, is that right? Don't forget to multiply by the derivative of the base. So, let's do this. This is going to be 4, 3x minus 1, 4 minus 1, times the derivative of 3x minus what? 1. You guys okay with that? What's this derivative? What do you guys think? What's that derivative? Is that 3? Is that true? Remember, what are you guys looking at here? This is called the chain. You're looking at the chain portion. So you're now going to get what? Here's what you guys are going to get. You're going to get this 4, 3x minus 1 to the third power times 3, and then multiply your constants. 4 times 3, you get 3x minus 1 cubed. Okay, so here's that derivative. So here's chain rule, but ladies and gentlemen, it's a operator notation version. Okay, do you guys like that picture, by the way? I don't know. What if they give you, we'll do some more chain rule. I know I did. I thought, wow, okay. What if they gave you y equals cosine pi x? Okay? And yes, they want you to find what? Y prime. So, let's give you guys what we gave you, what I wrote down before, okay? Let's give you a operator notation version. So if your function is cosine of some argument inside here, this is called the argument of cosine, right? So what's the derivative of cosine? It's minus sine times that derivative. So you're going to say minus sine times pi x times the derivative of what? Pi x. Okay? So this is minus sine of what? Pi x times, what is this? Times pi. Your derivative will be minus what? Pi times sine pi x. Okay? So, all right. I'm going to give you the f function, write it as a function and say, what if they gave you sine of 1/2 x, right? We're going to look at this operator notation of it. So the derivative of, because you might see it this way, right? You say, I'm using the product rule or quotient rule, and I have to differentiate this way with operator notation. So, again, if the function is sine of an argument, the derivative will be, what's the derivative of sine? cosine, and then don't forget to take the derivative of the argument. So here's another picture. Function, and then what? Derivative. So what's the derivative of sine of 1/2? What would you guys write down? You would write down what? Cosine of that 1/2 x times the derivative of what? 1/2 x. And what does that give you? 1/2. 1/2 cosine 1/2 x. So here's our operator notation, ladies and gentlemen, for taking that derivative. And you guys know, you might say, wow, are they going to have me, you know, do these kinds of derivatives? This is the operator notation? Yep. Because what they can give you is a function like x tangent maybe what? 6x. Okay, so I'm going to kind of kick it up a little bit, not much, but show you guys again how you guys can use these purple versions of chain rule. You know, and that's kind of how when I learned it, I guess I had to learn it that way, but the derivative is, you say, what is this? X tangent what? 6x. So share with you guys why you care, right? What is this going to be? This is going to be product what? Product rule, is that right? So you're going to pull out you got two functions here. So let's kind of think of it this way. First function and then what? Second function. So you're going to pull out what? First function. That's going to be x. What's the derivative of tangent? Secant squared. Let me do this here. Let's do this, ladies and gentlemen. Let's give you, if your function is tangent, what's the operator notation of a derivative? It is secant squared of the argument times the derivative of the argument. And again, chain out here. It's a chain. So, if you had to, maybe you want to write this as a note here. You have to differentiate tangent of what? 6x. That'll be secant squared 6x times the derivative of 6x. Okay, so this is chain rule, but with the operator notation. We put the constant always in front. So 6 secant squared, this is what we replace this with. 6 secant squared of what? 6x. And then what's this derivative going to be? Can you differentiate x? 1. Good. So put it all together, right? F prime will be, you're going to have 6x secant squared of 6x. You say, how did we get that, right? How did you get that? There's already an x, and you got what? This. So x times 6, 6 times x, okay? And then that's going to be plus what? Plus tangent times 1, which is tangent. There you guys go. Okay, easy peasy lemon squeezy. How about if they gave you, how about this? Secant x squared plus 5x plus 3. And maybe they put a constant like 4 in front. Okay? Let's get that derivative in operator notation. So you say, bless you, f prime x, right, becomes what? 4 secant x squared plus 5x plus 3 here, okay? So we're looking at these chain rule with operator notation. So using properties, right? What do you get to do with this? Pull out the what? The 4, and then differentiate the function. So this is operator. So we got the what? We got this 4 here, okay? So if we give you your function, and it's actually secant, you need that derivative. You say, what's the derivative of secant? You guys know the derivative of secant? It's secant tangent, but don't forget the what? Don't forget the chain. Okay, don't forget your chain. Okay, you guys okay with that? So you say, well, what do I do here? Well, we can say this is 4 now. Keep the 4. The derivative of what's in the triangle here? You see that there? So what you say here is secant now. What's that derivative? It's secant of x squared plus 5x plus 3. It is tangent of the same thing, so I need space. So we get tangent of the same exact thing. X squared plus 5x plus 3. Now don't forget times the chain. This is that derivative. What do you get now? This is times the chain here. Two x plus what? 5. F prime x is 4 times that 2x plus 5 times secant of x squared plus 5x plus 3. Oops, not secant squared, secant times tangent of the same thing. All right. There it is. Okay, you guys okay with that? Do you see the operator notation? Okay. So if they gave you, I'm going to keep it as F. I mean, even if they gave you Y, but yeah, let's keep it operator notation. What if they gave you the square root of 3 plus 4x to the 5th power? Operator what? Notation. Square root. 3 plus 4x to the 5th power here. Okay? You might say, can I change that square root? Yes, you can. Change it to what? 1/2 power. Is that true? Isn't that what the square root is? You guys with me on that? Okay, so why would I say do that? I want you guys to see the what? Power rule version of chain rule. Okay, where your base here is going to be what? What you guys see in here, that's the base. Okay? So let's see, what do you guys get here? This is going to be now what? One half 3 plus 4x to the 5th power, 1/2 minus 1, and then what? This is the chain. This is the part they want you to do what? Not to forget. Do you guys happen to know what that derivative is, by the way? What's this going to be? Isn't that 20x to the 4th? Is that 20x to the 4th, ladies and gentlemen? Right? So you guys see what I'm saying? You're going to need to tackle those details. So that's now going to be 1/2 3 plus 4x to the 5th, and then that's to the minus 1/2 power times 20x to the 4th power, right? You guys good with that? Okay, now, what's going to happen with those constants? Let me share with you guys how you want to do this, okay? 1/2 times 20 is 10. Is that true? And then you keep x to the 4th over here. And then that's 3 plus 4x to the 5th to the minus 1/2. Okay? You're almost done. You're almost done. What do you guys do? You write this as 3 plus 4x to the 5th power to the positive 1/2. Because isn't that what a negative power is right here? Is that what a negative power is? You guys okay with that? I can't seem to get my highlighter. Okay, now you're looking back at the book. What do you think you guys will see in back of the book? Yep, they're just going to put the radical now. And ladies and gentlemen, there you guys go. Okay, you guys okay with that one? So what I'm going to do for homework is I'm going to try to give you guys some book work for homework. I don't think I'm going to give you a lot because I gave you already my worksheets. I look at my worksheets as the bridge between doing calculus and the book work. So I say, okay, I think people need to work on these little details before you tackle some of those questions in the book. So I'll give you some derivative questions. So I want you guys to do some derivatives this weekend, right? Because again, what will eventually happen is some algebra like you guys seen up here. That'll eventually happen. Okay? So that's kind of coming. The algebra is coming. The factoring is coming. But you can't do anything. I mean, unless you could do a derivative, you won't even get to the algebra. So you have to be able to do the derivative first before you get to the what? The algebra, and you apply what you're learning. I mean, that's the idea behind it. So I'll give you guys some book work. I'll look it up, and I have a meeting today, so I don't have office hours today because I have a meeting to let you guys know. Anyway, so yes, we'll give you some book work, and hopefully you guys get some good, healthy practice on somewhat derivatives. Hopefully you guys learned something here with even chain rule. Did you guys learn anything?
Yes.
Let me ask you, do you prefer the operator notation or do you prefer the other notation?
Operator.
Don't know. Don't know.
When do you use this one and when do you use the one that we did?
In my opinion, the question is, when do we use operator notation and when to use the first one? In my opinion, when you first learn chain rule, you learn it the way we did yesterday. It's even in your book. But as you start to notice patterns here, you go, oh, then this is very helpful, the picture. So you're going to graduate, in my opinion, to the operator notation. So eventually you want to do operator notation. And I didn't put down all the trig functions, but there's a lot of other versions of questions you guys can see here. You know, I'm just looking at my notes, and I can do this stuff all day long with the different permutations. But you do have to practice it, get your hands dirty, think about it before you start to master it. And then now you can do it in your sleep if you do that. And I could do this stuff in my sleep. I'll forget my name, but I won't forget how to do a derivative.
So the first one, what's his name? What's it called?
The first example?
No, the one you used previously.
Well, you're just using it like by definition. It's still chain rule like by definition. Anyway, okay, you guys take care. Have a good day. We'll see you next week. So, okay, ladies and gentlemen, let's take a look here. What's going on? I want to remind you all that we record the lectures, and they are where? They are under the module section titled Lectures, and then they're listed by the date. Is that right?
Yeah.
Good. Okay. Now, I'm going to go to 261, and we're going to take a look a little bit about chain rule notation for you guys. And, you know, maybe in the future I'll make a video of this. Where are we at? Derivative chain rule operator notation. So I started to give you guys already some operator notation. Is that right? Do you guys know what I'm saying? So let's do a little bit more of that, because it transitions nicely into, you know, where we're headed. So I just want to share with you guys that location in case you wanted to know. We'll put it in the comment section. And I'm looking at it right now. So let's give you guys somewhat. How about this? Let me go back. Where am I at? Let's go to www. I'm going online here. So let's see. I'm going to have you guys try some of these out. How do I change that? Derivative of cosine squared 2. Differentiate cosine x squared and 3. How about the square root of cosine? Okay, and 4 yeah, we'll do this. Okay. So I'm going to have you guys warm up with chain rule notation for these functions, and we'll see how it goes. Okay? All right, let's get out the clock. If I can find it. Let's see what you guys get. Okay. So this is chain rule, and I should say with not notation, but yes, it's notation. Let's be more specific. What kind of notation is this? Operator notation. Okay. All right, now let's see if you guys know what we're talking about with this. I know they're all cosine, but you know, just you guys can compare and contrast these situations here. So I think what's important to note for people is what? What does that mean if you have cosine with this power 2 there? You guys know what that means? Sometimes people don't know what that means in terms of their notation, so let's kind of talk about what that means. Okay, that means you have what? Cosine to the second power, by definition. Okay? All right, you guys see the point. What is happening then is cosine is your base and 2 is your what? Power. Is that right? So how do you guys handle this? Remember that kind of, remember I give you this sort of situation here? You got what? If you have a, this is really power rule, right? So it's n triangle n minus 1 times the derivative of the base there. This is referred to as the chain. Okay, if you guys remember that. Here's your what? Chain. So this is the power rule version. Now what does that mean? Well, it means I have 2 cosine of x, okay, 2 minus 1, which is 1, but by the chain, differentiate what? Cosine, okay? You guys okay with that? And now what's the derivative of cosine? Negative sign. So ladies and gentlemen, all together, you end up with what? Here's what you guys end up with. It's going to be what? 2 cosine x, excuse me, minus sine x, and put the negative sign in front. So 2 cosine x, sine x. Ladies and gentlemen, there you go. Easy peasy what? Lemon squeezy.
Professor, I have a question.
Yeah.
Can we write it in negative sine 2x?
Negative sign. No, it depends what you mean by negative sine 2x. This 2, so you guys know, that 2, this constant never gets multiplied to what's inside the argument. This is
Yeah, but you can transform it using like trigonometrics like a
okay, no. But let me finish that just so some people think that can I ever multiply 2 with the x or any? No. It's functional notation like f of x. Can I write an equivalent identity here? You can, but you don't have to. This is just really what? Can you work with operator notation for chain rule? Okay. And this is probably something that I have not shown people really yet. So this is why I'm doing it. I'm showing you guys now. Okay, you guys see my point? So you say, okay, I think I've shown you something like this, though. But my point is, can you compare and contrast? Can you apply that? You know the difference, right? So now you say, well, what do you mean? Because I want you guys to compare and contrast all of them. What about this here? What am I looking at now, taking the derivative of cosine 2x? Well, if you have cosine of a function, you say, what's the derivative? Derivative of cosine is what? Negative sine of that function times the derivative of the argument, what's inside, right? So this is a different situation than what you guys see here. Okay, it's a different situation. So I want to share that with you guys. And so that means I have minus what for a derivative? Minus sine of x squared. Now times, this is the chain again, the derivative of what? X squared. So again, sometimes people, they never deal with the derivative of the chain. This is kind of thought of as the chain. And that derivative is what? 2x. So altogether, you're looking back at the book, you see minus 2x sine of what? X squared. That's what you'll see. Okay?
So we're using triangles to like represent what's inside.
Yeah, I use the triangle. You can use U. You know, the book, and sometimes, you know, people say, I'd rather do what the book does. You know, the book might have it this way. This is the U. This is the U. And then that's U prime, which is du dx. You know. So there's various ways to do that. I'm just going back to the Jaime Escalante version where he wrote that with triangles.
But it's okay. We could like use any font, right?
Yep. Number 3, ladies and gentlemen. Number 3 is a little bit similar to number 1. Why do I say that? Number 3 and number 1 are very similar. Do you guys know why? Why is that similar? d dx of what? What does that mean? Well, you still have cosine, but now the power is what? 1/2. So the base here is cosine now. Okay? So you say, is this my base? Yes. And then what's the power going to be? 1/2. So ladies and gentlemen, you're back to using what? The first one. Okay? So you're back using this. Now, what does that mean again? Well, we have to use the power rule, right? Which is going to be what? 1/2 cosine of x. Put that in your parentheses. 1/2 minus 1. Now the chain, the derivative of what? Cosine, which you guys know is really going to be what? Minus sine. So do the arithmetic. Isn't that 2 over 2? So I get 1/2 cosine, and that's minus 1/2 times negative what? Sine. Minus sine over what? 2 square root of what? Cosine. Is that true? Yeah. And there you go. I guess we're highlighting it blue. So double check, ladies and gentlemen. You guys are good with that? Does that seem okay? What do you guys think? All righty. All right, let's try this one here. You say, oh, how is this question? It's very similar. Okay, so this is going to be, again, here's my base, and then here's my what? Power. Is that right? So we're going to use, again, power rule with chain rule. Okay, you guys with me on that? Okay, so you say, what does power rule with chain rule work? How does that look? That's 1/2 again. Cosine 2 pi x to what power again? 1/2 minus 1. Don't forget your chain. And that's cosine 2 pi what? X. You got to take that derivative. So here is the chain, ladies and gentlemen. Okay? Just like up here, this was the what? The chain. Okay? Here, this was the what? The chain. And everybody forgets that. They go, nope. Chain. So every one of these had chain there. So notice this here. This derivative, we'll say, what is that going to be? Well, now I have to use what? This. Is that right? And you say, well, I don't like the u. Okay. Okay, do you guys see my point? You say, okay, what's the derivative of cosine of that 2 pi x? Well, it's minus sine of what? 2 pi x times the derivative with respect to x of 2 pi x. Is that right? Don't forget that this also has a what? A chain. Okay, you guys with me on that one? You're differentiating cosine 2 pi x. So now, what's the derivative of this 2 pi x? You guys know that's going to be what? 2 pi. But don't forget everything that you have here. Don't forget we have this portion here. I'm going to go back to highlighters. I have this component, not to forget. Okay, I have this component, not to forget, and then I have this component. Okay, so double check, take a look, get a good look. Okay, so let's kind of not forget the gray. So that'll be, if I write it down, 1/2 cosine 2 pi x, that whole thing to the minus 1/2 power, okay, times negative sine 2 pi x times 2 pi. So I would say to you, what? Don't the 2's cancel? So we're going to have negative pi sine 2 pi x as a numerator over the square root. We'll put that as a square root here of cosine 2 pi x. And that negative sign you can see in back of the book right here in front. So anyway, and there you go, ladies and gentlemen. Okay, what do you guys think? Is that easy peasy lemon squeezy?
Depends.
Well, let's try this out. Let's see if you guys are awake. Derivative of sine cube of pi x. Number 6, I'm going to look back at my, where is it? Where'd it go? Derivative tangent of 1/2 x 3/2 power here. Number 7, derivative of secant of tangent 3x. Actually, let me change that 3. Okay, just to compare and contrast. Square root of x.
Professor, what's the power of like
3/2. All right, now, just like before, what are you guys really looking at here? Okay, this is going to be what? Power rule. So I'm going to go back and find that power rule again. It's really power rule with chain rule, right? Okay, so you say, well, what does that give us? That's going to give us what? 3 times sine of pi x. Okay, and then that's going to be 3 minus 1. Is that true? Now, don't stop right there. Let me write pi x a little clearer. Don't stop right there. You now have to differentiate. Don't forget the chain. Sine what? Pi x. So do not forget your what? Chain. But when you differentiate here by the chain, or I should say differentiate the chain, you're going to say, what is this? Well, you need to have another function, I think, right? I think we wrote this down last time. Now, I don't know. Would you guys prefer letters or do you prefer the shape?
Maybe shape.
Doesn't matter to me. You guys see my point? So, if I just said to you, here is, oops, sorry. If your function is sine u, maybe you prefer that. The derivative is cosine u times what? Du dx. So the derivative of sine will be what? Cosine pi x, but now again, don't forget to differentiate pi x with respect to x. Because again, you have another chain right in here. This is the chain portion. You need to know the derivative of pi x, which is going to be what? Pi. So just make sure, ladies and gentlemen, that you go back and remember everything that's what? Here. You don't want to forget any of this because it's all part of your answer. And then, of course, what's 3 minus 1? Isn't that 2? So I would start off by writing things down again by saying that's 3 sine squared pi x times cosine what? Pi x times that pi. So now you could put your constants together and say 3 pi sine squared pi x cosine pi x. There you go. So double check, ladies and gentlemen, if I have every detail here. But this is chain rule, again, even within chain rule. So notice I'm following all of what to do by just using my operator notation. Okay, you guys see that there? You see every detail? Operator notation. I can do that in my sleep now. Because all you got to do now is practice, practice, what? Practice. Okay. So this is tangent of what? 1/2 x raised to the what? 3/2 power. Okay, and then you're going to use what again? Maybe you want to see it this way. If my function looks like this, maybe I don't want to see those things. I want to see it in terms of u. I think, does the book do it that way? Okay. So, 3/2 tangent 1/2 x 3/2 minus 1, and then don't forget the chain, okay? Because the chain here right? This portion here is what we call the chain and chain rule. So I'm going to have to differentiate now tangent 1/2 x. Don't forget, 1 is 2/2. Okay, now, again, I don't think we have the chain rule version here, but I'm going to write it down here for you. Okay? So if your function is tangent u, I'll switch to that, to the book notation. What's the derivative of tangent? So it's secant squared u times du dx. Again, the what? Chain. Okay? So this portion is going to be, for us, derivative of tangent is secant squared 1/2 x. Now, again, chain rule, take the derivative of 1/2 x. So I'm really using the book's notation. And what's the derivative of 1/2 x? Isn't that just 1/2? Okay, so highlight your terms, because you can very easily what? Forget what's really here. All right, so now, what's 3/2 times 1/2? Right? You might say, what are you doing here? Well, I take the constants. 3/2 times 1/2, isn't that going to be 3/4? 3/4. Tangent 1/2 x. 3/2 minus 2/2, isn't that 1/2? So that's a 1/2 power there, times secant squared 1/2 x. And you might even see the 1/2 gone. They might even just put what? Square root. So, ladies and gentlemen, here's your answer. Again, using what? Chain rule. Okay? Every gory detail. What did you guys think? You said, boy, they can have me do chain rule within chain rule even? Yes. Let's see how this one goes. Is this one kind of scary? Well, what do we have to do this one? Right? If the book says you have secant of u, the derivative is, what's the derivative of secant? Secant tangent, right? And times du dx. So you say, is that secant tangent square root of x times tangent square root of x? And don't forget the chain. The derivative of what? Tangent square root of x. So this is the chain here, okay? That's a chain and chain rule. So don't forget that. It's the chain and chain rule. So secant u, tangent u, du dx. What you have to use now, again, here, what's the derivative of tangent of u? Okay? So I'm going to say, if your function's tangent u, the derivative is what? Secant squared u times, by chain rule, du dx. So it's operator notation and chain rule again. So that portion will be tangent square root of x. Oops, not tangent. secant squared square root of x times by chain rule the derivative of square root of x, square root of x. Now, what's that going to be? And there it is. There you guys go. So we just have to write everything down together now, okay? Okay. So what I'm going to do here is I'm going to copy this because we're completely out of space. Copy that. Okay, we're out of space there. And then this is times what? Don't forget it's times what? Secant squared square root of x times that 1 over 2 square root of x. So, darn it. It's going to be odd notation. I'll put it this way. Put it as a denominator, okay? But don't forget, this is that multiplication here and here. We just don't have enough space here. Okay? So there you go. Okay? All right. Operator notation. Now, you might say to me, why did you want to review all this today again? Chain rule with operator notation, go over some additional examples. Well, there's always a couple of reasons. I think it's good to see these things because you might see them in some of that book work. Is that right? Did I assign any book work for you guys?
Yes, you did.
Oh, thank you for noticing. I even sent that to you all.